Let's find a limit. The instructions are to find a limit or show it does not exist, and we're looking at the limit as xy approaches to negative 1 of x squared y plus xy squared over x squared minus y squared. I see that we can factor in the numerator and denominator and thereby simplify the expression. However, I also see that by letting x equal 2 and y negative 1, I don't have a 0 in the denominator, and so I actually can find a limit by direct substitution, and that's what we're going to do. Substituting x is 2 and y is negative 1, we get 2 squared times negative 1 plus 2 times negative 1 squared, all divided by 2 squared minus negative 1 squared. We can find that this evaluates to negative 2/3. There's our limit. We can move on. And we will. We're now going to look at the limit as xy approaches 0, 0 of 5y to the 4th times the cosine squared of x divided by x to the 4th plus y to the 4th. Direct substitution yields us 0 divided by 0, which is indeterminate. Our expression is not one in which we can use algebraic or trigonometric manipulation to simplify the expression. And so what we do is we're going to explore by checking or finding the limit along multiple paths. First, we'll try along the line x equals 0. Then we're looking at the limit as 0y approaches 0, 0. You see what we've done is we've replaced x by 0 even in the limit statement. And in the expression, what we end up with is y to the 4th times the cosine squared of 0 divided by 0 to the 4th plus y to the 4th. This becomes the limit as y approaches 0. Y is the only thing that's changing here, of 5y to the 4th divided by y to the 4th. And we end up with an answer of 5. Now that doesn't necessarily mean the limit is 5, but if there is a limit, it will be 5. Let's check now along the line y equals x. We'll then have the limit as x approaches 0 of 5x to the 4th times the cosine squared of x divided by x to the 4th plus x to the 4th. And you may ask yourself, what happened with y? Well, we're letting y equal x. And so everywhere we had seen a y before, we now have an x. By simplifying and dividing, we see that this becomes the limit as x approaches 0 of 5 times the cosine squared of x divided by 2. And now direct substitution yields 5/2. What we now have are two different results. You may recall that we said for a limit to exist, it must be the same limit along every path that contains the point of interest, in this case 0, 0. If along one path we have a limit of 5 and along another path we have a limit of 5/2, then the limit does not exist. Our work for this problem is done. Let's see what the graph of the function looks like so we can better understand our results. I've used the GeoGebra 3D graphing tool and I've entered our function z is equal to 5y to the 4th cosine squared of x divided by x to the 4th plus y to the 4th. And we have this kind of undulating, ripply surface here. The red axis is the x-axis pointing down to the left, and the green axis is the y-axis pointing over to the right. As we can see along the y-axis, the function value is 5 along this ridge up here. Along the x-axis, the function value is 0. Those in and of themselves aren't really a problem. And it's difficult to see what's going on with this function from this view. If I zoom in though, then you can see that there exists a gap around the z-axis. And if I rotate the image a bit, then you can see that if we approach along various paths, we're going to land at different places before that gap. Therefore, the function values, the limit values along various paths won't match. And so this is a picture of an example where the limit does not exist. Now, we'll never consider infinite paths, of course, but it might be useful to note what kind of paths we can consider. What I'm going to write down right now are paths to consider if we have xy approaching 0, 0. we can find limits along y equals 0, x equals 0, y equals x, y equals x squared, y equals the square root of x, y equals x to the fourth. These are common paths that we can consider in finding limits, and you'll see some examples of those as we move on. One of the keys, though, is to keep in mind that all of these paths contain the point 0, 0. I must use a path that's going to contain the point of interest.